Dear young florists, welcome to OREVEINS Education's Algorithm Classroom. I am your lead programming instructor for today. In Lesson 7 of Level 3, we are going to witness a marvelous collision of mathematics, aesthetics, and computer science. In our previous lessons, you have already worked with data lists and basic variable controls. Today, however, we are launching a truly exciting challenge, taking the abstract combinatorial algorithm of multi-list initialization plus index variables plus nested loops and making it completely concrete and visible. By pairing it perfectly with Scratch's unique pen stamp feature, we will dynamically create a grand royal flower show on our stage in the blink of an eye. This underlying logic is not just for arranging flowers. It is the master formula used in computer science to solve all combination problems. Let's infuse our code with a touch of digital sorcery and step into today's creative scenario. Welcome to the annual Royal Flower Arrangement Competition. Today, our young florists have received a challenging puzzle issued by the Queen herself. In Her Majesty's Royal Storage Room, she has prepared two types of foliage, lucky bamboo and eucalyptus, two types of primary flowers, lily and anthurium, and three types of secondary flowers, delphinium, daisy, and pompon mum. The Queen wishes to display every single possible arrangement in a straight line across the castle's outdoor plaza. Can you help Her Majesty calculate exactly how many unique potted arrangements we can create? That's right. According to the multiplication principle in mathematics, we have a total of 2 times 2 times 3 equals 12 distinct combinations. If we were to arrange them by hand one by one, we wouldn't finish even by dawn. Fortunately, we possess a magical tool, our code. As long as we program our master combination algorithm, our sprite will act like a high-precision printer, dynamically stamping all 12 flower arrangements across the stage instantly. To manage so many plants systematically within our program, we must first build a clean database behind the scenes. We prepare 4 important data lists: foliage to store the green accents, primary_flowers for the focal flowers, secondary_flowers for the filler flowers, and flower_arrangement ledger to automatically record each completed arrangement. We also create 3 index variables: foliage_index A, primary_index B, and secondary_index C, which act like pointers that keep track of our current choices in each list. Finally, we use 2 layout variables, X position and Y position, to control exactly where each flower pot appears on the stage so they don't overlap. Clever design tip: we don't need a separate sprite for every flower. Instead, we use just one sprite named magic_basket that contains 8 different costumes. By switching between these costumes and stamping them on top of each other like building blocks, we can create rich, layered flower arrangements using only a single sprite. The order of the costumes is very important because it connects directly to our mathematical formulas later. Costumes 1 to 2, foliage, lucky bamboo, eucalyptus. Costumes 3 to 4, primary flowers, lily, anthurium. Costumes 5 to 7, secondary flowers, delphinium, daisy, pompon mum. Costume 8, basket, the base. The logic of this lesson can be broken into 3 major phases: environment initialization, 3-layer nested loops, and dynamic multi-costume stamp rendering. 1. Environment initialization. When the green flag is clicked, we must make sure the stage is completely clean. We use Erase All to remove any previous drawings and clear the flower_arrangement ledger list. At the same time, we set our starting coordinates so the magic basket sprite begins at the left side of the plaza, ready to build the display from left to right and top to bottom. 2. Clockwork precision, the 3-layer nested loop mechanism. This is the heart of the lesson. To generate every possible combination without missing any, we nest 3 loops inside each other. The outer loop handles the foliage, 2 options. The middle loop handles the primary flowers, 2 options. The inner loop handles the secondary flowers, 3 options. You can imagine this algorithm like the mechanism inside a clock. The inner loop, secondary flowers, runs the fastest. After it completes its 3 steps, it resets itself and allows the middle loop to advance. Only after the middle loop finishes its 2 steps does the outer loop move forward. This synchronized movement ensures we explore all 12 combinations systematically. 3. Stamp layering and 3D spatial offset rendering. Inside the innermost loop, once our 3 index pointers have selected a unique combination, we create the visual magic. We move the sprite to the current position and stamp the basket base. Then, we slightly adjust the Y position upward to stamp the foliage layer, adjust again for the primary flower, and once more for the secondary flower. These small vertical offsets create a beautiful, layered, 3-dimensional effect. After each complete arrangement is stamped, we shift the X position to the right to make space for the next pot. When a row becomes full, after 6 pots, we automatically move back to the left side and drop down to the next row. The magic of pen blocks, erase all, teaches us the important habit of proper initialization. The stamp block is especially powerful. It leaves a permanent image on the stage background, like pressing a real ink stamp on paper. This allows one sprite to build an entire garden of layered arrangements efficiently. Costume index offset. When switching costumes, we don't use fixed numbers. Instead, we use mathematical expressions such as adding an offset. For primary flowers, we add 2. For secondary flowers, we add 4. This clever technique maps our index variables to the correct costume numbers automatically. It's a beautiful example of how mathematics brings flexibility and power to our code. The critical reset. One of the most important details is resetting the secondary _index_C back to 1 after the inner loop finishes. Without this reset, our pointers would go out of bounds and the program would not work correctly. This small step is often what makes the difference between success and failure. Once you master this multi-list initialization plus index variables plus nested loops framework, you have learned the classic master combination algorithm used throughout computer science. This same structure can power fashion outfit creators, restaurant menu generators, password testers, and many other real-world applications. The beauty is that one strong logical pattern can solve so many different problems. This lesson is a perfect blend of programming, art, and mathematics. If the index pointers or loops feel tricky at first, don't worry. Reach out to your OREVEINS Education instructor. We are always happy to help you understand. Thank you for joining today's class. Keep creating beautiful things with code. See you in the next lesson.